So I talk about the recirculation and the rule of energy recovery now and in the future. At first, we have to make clear about what kind of air handling unit we are talking. There is the fresh air handling unit. It's a air handling unit who takes out on one side the room air and brings in on the other side the outside air, the fresh air. And then the other kind of air handling unit is the recirculation air handling unit, is a unit who recirculates the air in the building, and it's mainly used to cover the cooling load in the Middle East applications. After more than 6 months of experience with the pandemic, all the experts are sure that the SARS-CoV-2 virus brought more importance to the energy recovery, and it reduces the possibility of recirculation air in the fresh air handling units. I will inform you about the transmission route of SARS-CoV-2, about recirculation mode, the energy recovery, cleaning maintenance and UVC lamps, and finally a summary. There are 3 different transmission routes of the SARS-CoV-2 virus. The first one is droplets and aerosols. You have it in a small distance when you talk or when you breathe. The second one is the surface contact transmission, so the handshake or other surfaces. And the third one is airborne transmission. When you have a look on a closed room indoor, and there are inside many people, so the concentration of the virus gets higher and higher, and so the risk that you transfer the sickness to another person through the air getting more and more. When you switch on the ventilation system, the air handling unit, you reduce the concentration in the room dramatically, and so you also reduce the risk that that you get the illness or you get the virus in your body. So the fresh air handling unit have a very important rule to decrease the airborne transmission of the virus. For that, you have to increase the exchange rate, so change as much as possible air in the building, and increase the fresh air rate. More fresh air gives you a better result to decrease the airborne transmission. Also, a way is to ventilate the building, the room, before it's occupied, so increase the operation time before and after the regular period, switch it on, ventilate the room, that when the people are arrived, the indoor air quality is very high. Recirculation mode in fresh air handling units. This is the situation that you have on the exhaust air side, a mixing air box with a temper system, and depending on the outdoor conditions, you use also the recirculation air to cool down the building inside. But in our time with the SARS-CoV-2, recirculation air must be reduced to a minimum. And if you cannot avoid, it's as my colleague before told you, the filtration is very important for the exhaust air. You should use EPM1 filters or HEPA filters when it cannot avoid recirculation air. The disadvantage of these high quality filters is that the pressure loss is very high. So when you have existing installations and you add some kind of these high quality filters, the air volume will go down, and it's very difficult to get in the cooling load in the building when the air volume goes down. So better use the recirculation air mode in fresh air handling units. Now we come to energy recovery. Energy recovery, there are two main systems on the market. This is the rotary heat exchanger and the plate heat exchanger. We start with the rotary heat exchanger. The rotary heat exchanger has a storage mass. The storage mass is made by aluminum, very thin aluminum, and could be covered by absorption material. Absorption material is 3 angstrom molecular sieve or a silica gel. And then you have a casing. And this heat exchanger is built in the air handling unit. The function is that the storage mass is turning like a wheel, and then you have on one half the exhaust air and on the other half the fresh air side, and then the storage mass is heated up, cooled down, or take the humidity and transfer it to the other side. The advantage from the system side is that with the rotary heat exchanger you can transfer the temperature and the humidity very easily. And humidity is a key issue in the application in the Middle East region. The other system is the plate heat exchanger. The plate heat exchanger, you have a exchanger package. This is also made from aluminum plates. They are double folded at the end to make them tight, and then you make a package. And then you have a casing around. The airstreams go in cross flow. One airstream goes this way, the other airstream go that way, and the energy transmission works through heat conduction. When we talk more in detail about the rotary heat exchanger, he gets under pressure with some information on the market that it's very critical to use the rotary heat exchanger in time of SARS-CoV-2. There are one important issue. This is the exhaust air transfer ratio. The exhaust air transfer ratio is the air volume in percent what will be transferred from the exhaust air side to the fresh air side. And this ratio is a function of the pressure difference between the supply air side and the exhaust air side, the type of the sealing, the rotor speed, and the purge sector. The main target when you use the rotary heat exchanger for energy recovery in our time is that you keep an overpressure on the supply air side, that the air don't go from the exhaust air side to the supply air side, vice versa, from the supply air side to the exhaust air side. What are measures to keep the exhaust air leakage very low? The most important part is the correct position of the fan. With the correct position of the fan, you can avoid that exhaust air moves to the supply air side. The best configuration and most used configuration is the both fans after the rotor. So the exhaust air fan is before it goes outside, and the supply air fan is after the heat exchanger. And here you have to set the pressure that the supply air pressure is all the time higher than the exhaust air pressure side. You can set this with throttles or some damper system that you make sure that the supply air pressure is higher than the exhaust air side. When you have both fans on the building side, there is no way. Here, it's not possible that you bring a situation that the pressure on the supply air side is higher than on the exhaust air side. Also possible is both fans on the outdoor side. Here, this fan is sucking, this fan is blowing, so you all the time have the situation that the air moves from the supply air side to the exhaust air side. Both fans upstream to the exchanger, also possible, but you have to set the pressure levels that at least the supply air side pressure is 20 pascal higher than the exhaust air side pressure. Other things to do is you have to keep the carryover low. The carryover is the air you have in the matrix when it's turning, and then you have the exhaust air inside, and then it moves to the fresh air side or supply air side. For that, you have the possibility to use purge zones. And the purge zone must be set on the right angle in the right part of the wheel. And there are recommending documents in all design handbook. What is the right angle of the purge zone and what is the best position? The sealing of the wheel. A key thing also. You have the sealing around the wheel, and you have the middle beam sealing. So look to suppliers who have a high quality of sealing system on their product to avoid leakage on the rotary heat exchanger. The other system, as I told you, is the plate heat exchanger. The plate heat exchanger has in practice is airtight. When you have a pressure difference of 250 pascal, the leakage is less than 0.1%. So we can talk about a tight system, airtight system with the plate heat exchanger. At the moment on the market, the plate heat exchangers are made from aluminum fins and cannot transfer humidity. In the residential ventilation, it's quite common that they use plate heat exchanger with some membranes who also can produce humidity. To upgrade these products, it needs a little bit more development work because at the moment the solution is a little bit too expensive, and some companies are on a good way to bring a plate heat exchanger on the market with also humidity transfer for reasonable prices in the near future. Hygienic on air handling units, a big issue all the time. So the cleaning and the maintenance is very important to keep the quality level of an air handling unit. You have to do it regularly. From the energy recovery side, you have to clean the rotor matrix, you have to change the sealings, you have to adjust the belt. Also, what is now under discussion is UVC irritation in the supply air. They're running some tests how efficient the system is for the SARS-CoV-2 virus, and there will be some update about solutions like this in the near future. Now come to my summary of the presentation. Fresh air handling units have an important role to decrease the airborne transmission in the time with the virus. We have to increase the fresh air ratio to give a better air quality in the building. For the fresh air handling units, we do not recommend to use recirculation mode. Maintain and clean the fresh air maintain and clean the air handling unit regularly, and both main energy recovery systems, heat wheel and plate heat exchanger, can be used without risk if correctly designed. Thank you very much.
Thank you as well, Stephan. in an earlier document, I think back in March, there was once a recommendation floated to switch off the rotary heat exchangers. Is that a definite message of your side to not switch off such devices and first look at what they do for the system, because you also create problems with humidification? Is that a statement from your side which we can give?
Yes, Marcus, this was the first information what goes out, and after discussion with the experts, it's very clear that when the design is correct, there is no risk with the rotary heat exchanger also in the time with SARS-CoV-2. These are
Okay.
the clear message from the expert side.